class. Exponents, right?
Yeah.
And what probably gives you the hardest time are these guys. Maybe that's my guess. So you have a radical. This is in radical form. In order to deal with this, you have to translate it to fractional exponents. Yeah, so the cube root is the same as x to the 1/3 power. Okay? So this is x to the 1/3, x to the 3/2, x to the -5/6, all over. And then the square root of x, I don't know if Frank talked to you about this, but there's an imaginary 2 there all the time. Okay? You're trying to pull out a pair, 2 of a kind. Okay? Here you're trying to pull out 3 of a kind. So this I can rewrite as x to the 1/2. So that's the first move. You can translate it. Now there's no real multiple choice strategies you can use on it. You kind of just got to solve this. Can you combine these?
No. Not yet.
What operation am I going to have to use to combine them all? Addition, right? I'm adding, but the only way I can add them is if I get the same denominator. So what's the common denominator here? 6. All right. So x to the 2/6, x to the 9/6, x to the -5/6, and x to the 1/2 would be x to the 3/6. Now in terms of strategy, what do you think the best move is next? Should I deal with just the top, or should I deal with the top and the bottom?
Just the top.
Just the top, yeah.
Hey, how did it move the -5/6 to the bottom? Just like
I didn't move it here because I don't have a common denominator yet. But you could move it. I mean, this might be easier. You could move it here. I think the easiest way to do this now, if you know you're adding, is literally just to add all the top ones and then figure out the bottom. So go ahead and do that.
x to the 1/2.
So you get x to the 11 minus 5 is 6, right?
Yeah.
So x to the 6/6 over x to the 3/6. And then you can think of it this way conceptually. I have 6. Is that right?
Yeah.
Yes. I have 6 on top and 3 on the bottom. How many do I have left? 3. Where are they? On top. So you have 3 on top, and it's all over a fraction of 6. 3/6 an answer?
No, that's 1/2.
Okay, I was just making sure. That would have been really cruel if they would have done that.
You didn't have to do the bottom.
What was that?
Bottom. Multiply the bottom.
All right, so 663. It's a good problem. Again, this is Frank's class. This is algebra. So here we are. This is called a polynomial, and you have a polynomial with multiple x-intercepts. But another word for x-intercepts is roots, zeros, solutions. You might want to write this down because this might translate to a lot of problems. Remember on the old CST, they'd ask a lot of questions like this. All of these 4 words mean the same thing. Now, the key here is when you're writing a polynomial, if you can find these x-intercepts, we can actually write the whole polynomial out. Because those x-intercepts are also the solutions. And the solutions, when you solve a polynomial or a quadratic, you always set it equal to 0, because they're the same thing. Remember, if one part of this expression is 0, the whole thing's 0? 0 times one number is going to be 0. So, this is how easy this is. Your x value here is 4. The only way to get 4 would be to do x minus 4. Right? If you plug 4 in here, 4 minus 4 is 0. This would be x minus 2. 2 minus 2 is 0. What are the other 2? Find the other 2. X plus 3 and x plus 1. So what you end up doing is you write out this whole polynomial, x plus 3 times x plus 1 times x minus 2, and then I'm going to leave a space, times x minus 4. The trickiest part about this problem, and I don't know if Frank taught you this, because it's a very small detail, and it's probably where students are going to miss this, is this guy right here. You see this solution? It happens to land right on the x-axis. It doesn't go above or below, which actually means you have two solutions there. So, because you have two solutions, you have to write x minus 2 twice. And I could prove it with the algebra. We don't have time today. But general rule here, if you have a solution and it crosses it, you only write it once. But if it lands right on that x-axis, you got to write that solution twice.